Namaskar everyone. Today let us discuss virtual displacements for equilibrium. Let us restate the virtual work principle as in equation 1223. External virtual work is equal to internal virtual work. This principle can be expressed in mathematical form as 1 bar dot p equal to summation of u bar dot f, where 1 bar is virtual unit displacement at a nodal point in the direction of capital P. Capital P is real external nodal force. U bar is virtual internal displacements compatible with the virtual unit displacement. And capital F is real internal forces in equilibrium with P. So we can understand that in this method, we apply virtual unit displacement at the point of interest. As compared to virtual force method, where we used to apply unit virtual force at the point of interest. So here, the major difference is that we are applying virtual unit displacement at a nodal point in the direction of capital P. Let us try to understand this method with one example. So we are discussing now example 12.6, which says, using the virtual displacement method, determine the bar forces in the pin-jointed linearly elastic steel truss of example 12.1. So here is the truss. Here is the truss A, B, C. Here we can see that load of 3000 pound is being applied at point B. We want to find out what are the forces which would get developed in links AB and BC. To solve this problem using virtual displacement method, let us first of all try to see what happens if point B is displaced by delta 1 in horizontal direction. So in figure B, you can see there is a horizontal uh, displacement of delta 1 that has been given to point B, and now point B has occupied new position B dash. Due to this displacement of point B, there is a stretch of 4 by 5 delta 1 in link AB, and also a stretch of 4 by 5 delta 1 in link BC. This stretch can be obtained by taking component of delta 1 in direction of AB, and also by taking component of delta 1 in direction of BC. Again, let us see what happens if we give vertical displacement of delta 2 to point B, and point B thereby takes new position B double dash. Due to this vertical displacement, link AB double dash contracts, and there is a stretch in link BC. Link AB contracts by amount 3 by 5 delta 2, and link BC extends by amount 3 by 5 delta 2. Again, this can be obtained easily by taking component of delta 2 in the direction of AB and in direction of BC. Also, let us try to find out the stiffness of members AB and BC. So if we denote member AB by 1 and BC by 2 and call stiffness of member AB by K1, then we can see K1 is equal to A1E by L1, and K2 is equal to A2E by L2, where A1 E and L1 are area of cross section, Young's modulus of elasticity, and the length of link 1. Similarly, A2, E and L2 are area of cross section, Young's modulus of elasticity, and length of link 2. So K1 is equal to 75 kilopound per inch and K2 equal to 125 kilopound per inch. Now, we had seen that what is the effect on delta 1 and delta 2 on individual uh, stretch of or contraction of members AB and BC. So we can very easily now see that the uh, stretch of member 1 can be written as U1 equal to 0.8 delta 1 minus 0.6 delta 2. And similarly, stretch of member 2 can be written as U2 equal to 0.8 delta 1 plus 0.6 delta 2. So this U1 and U2 are given by these expressions if for a given value of delta 1 and delta 2. Now we can see that for these particular values of U1 and U2, the forces which would get developed in members 1 and 2 denoted by F1 and F2 would be F1 equal to K1 U1, that would be equal to now 75 bracket start 0.8 delta 1 minus 0.6 delta 2 bracket close, that is 60 delta 1 minus 45 delta 2. Similarly, F2 would be equal to K2 U2, that is equal to 125 bracket start 0.8 delta 1 plus 0.6 delta 2 bracket close equal to 100 delta 1 plus 75 delta 2. Now, now let us apply the principle of virtual work, the displacement method of virtual work. Now, in this method, we can write 1 bar into 0 equal to U1 bar capital F1 plus U2 bar capital F2, where 1 bar is unit virtual displacement that we have applied at point B in the horizontal direction. Into 0 because there is no real force which is existing at point B in the horizontal direction. Now this is equal to U1 bar F1 plus U2 bar F2. U1 bar is the virtual displacement of link 1 due to unit virtual displacement at point B in the horizontal direction. Now this would be equal to U1 bar, we can see, can be obtained if we put delta 2 equal to 0 here. So it becomes 0.8, and similarly U2 bar is virtual displacement of link BC due to existence of unit virtual displacement at point B in the horizontal direction. Now again, U2 bar would be obtained from this expression by putting delta 1 equal to 1 and delta 2 equal to 0, and that again gives us U2 bar equal to 0.8, right? Now F1 and F2 we have already determined here. 60 delta 1 minus 45 delta 2, that is F1, and F2 is equal to 100 delta 1 plus 75 delta 2. So if we substitute it here, then we get one equation, 128 delta 1 plus 24 delta 2 equal to 0. Now, let us again apply the virtual method, the displacement method of virtual work in the vertical direction for at point B. So we will apply unit virtual displacement at point B in the vertical direction. So due to application of unit virtual displacement at point B in vertical direction, we can write 1 bar into -3 equal to U1 bar capital F1 plus U2 bar capital F2, where 1 bar is unit virtual displacement applied at point B in vertical direction. -3 is the real force which is already existing at point B in vertical direction. As you can see here, point B is already experiencing 3K of real force in the vertical direction. And so 1 bar into -3 equal to U1 bar F1 plus U2 bar F2. U1 bar is virtual displacement of link 1 due to application of unit virtual displacement at point B in the vertical direction. So this we can obtain, U1 bar can be obtained from U1 equal to 0.8 delta 1 minus 0.6 delta 2. Here we will put delta 1 equal to 0 and delta 2 equal to 1. So we get U1 equal to minus 0.6. Similarly, U2 is virtual displacement of link 2 due to application of unit virtual displacement at point B in the vertical direction. So U2 bar would be equal to would be obtained, U2 bar would be obtained if we put delta 1 equal to 0 and delta 2 equal to 1. So we get U2 bar equal to 0.6. And F1, capital F1 and capital F2 we had already obtained. So we get one equation, 24 delta 1 plus 72 delta 2 equal to -3. So we can solve these two equations, 128 delta 1 plus 24 delta 2 equal to 0 and 24 delta 1 plus 72 delta 2 equal to -3, and we can easily get values of delta 1 and delta 2. Delta 1 equal to 8.33 milli-inch and delta 2 equal to -44.4 milli-inch. And if we substitute these values in the expressions of capital F1 and capital F2, we get capital F1 equal to 2.5 K and capital F2 equal to -2.5 K.